I wanted to create a quick file. Several of you have asked for a video about how to graph one complete cycle of, say, a sine or a cosine graph. So I wrote out an example here. The first thing you should do is, let's see if I can unlock, take what's called the argument, so the expression inside of the trig function, and put that between 0 and 2 pi. So in this case, 0 less than or equal to 3x minus pi less than or equal to 2 pi. The reason that you want to do that is because the basic cycle for y equals sine x, you get one complete cycle as x goes from 0 to 2 pi. And I'm going to go ahead and draw a sketch over here to the side. It's nice when you start a problem like this to have a picture in your head of what just the basic cycle for y equals sine x looks like. So the sine function starts and ends at the x-axis. I'm going to refer to it as sea level. Just maybe you've heard of this graphs of the sine and cosine functions referred to as the sine wave and the cosine wave. That's a nice way to think about it. And the sine graph starts and ends at sea level there. And it also hits sea level right in the middle. So between the first x value and that midway point, the sine graph goes up to its maximum at +1. And then between the midway point and that final x value, it goes down to its minimum value at -1. So like I said, it's nice to have just that general picture in your mind when you get started here. Okay, and then, yeah, I was speaking about the 0 to 2 pi. So the first x value in that standard cycle is 0, and it completes the one cycle when x reaches 2 pi. So this function, 3 sine of 3x minus pi minus 2, is going to complete one cycle when that 3x minus pi ranges from 0 to 2 pi. So that's why we set up this inequality. Now you'd want to isolate x to find the starting and stopping x values for one complete cycle. So in this case, I'm trying to switch colors. Let me see. I would add pi to all three parts of the inequality, so that we have pi less than or equal to 3x less than or equal to 2 pi plus 1 pi gives us 3 pi. And then divide all three parts by 3 to isolate x. Okay, and so this last x value, the 3's cancel. So we're going to get one complete cycle as x ranges from pi over 3 to pi. Okay, and solving this inequality takes care of all of the horizontal transformations. I'm going to draw a sketch at this point. I should probably get a new page though. I'm going to draw a sketch at this point for, sorry, I'm distracted by something else. The graph of y equals sine of 3x minus pi. So I'm ignoring everything outside of the sine function, which those values are going to correspond to vertical changes in the graph. So just accounting for the horizontal changes, we know that one cycle of that sine graph occurs as x ranges from pi over 3 to pi. And let's see, I'll draw the sketch over here so I can give myself some room. Okay, so I would go with whatever increments I see in my cycle. In this case, I would count by pi thirds. So I'll just label this first increment pi over 3, and then I'll draw a second increment, so that would be 2 pi over 3. I guess I'll label that one as well. And then the next increment would be 3 pi over 3, which is equal to 1 pi. And that's our final x value. Now, this is where it helps to have that picture of the sine graph in your head. So we know that the sine function starts and ends at sea level. Also remember, I'm not worrying about the vertical transformations right now. It hits sea level in the middle. And okay, this brings me to the other question that I've been asked a lot this week, which is how do you divide that interval into 4 equal parts? And one way to do it is to find the length of this cycle, so find the period for this graph, divide it by 4, and then add those fourths to the first value of x. You might have seen a video where that's done. Now, I don't mind if you guys just divide this thing into fourths the way you would like slice up a pizza or something if you were dividing it into fourths, which is, I mean, I would take this full cycle, let me get my little pointer, I would take this full cycle and first divide it in half, which we've already pretty much done here, and then divide each of those halves in half again. And I would just mark that. You don't necessarily have to label that. So I would take this first half and divide it in half here, and then the second half, divide it in half here. And honestly, labeling every single one of those x values is just going to clutter your graph anyway. So I'm perfectly happy if you have just the 4 equal spaces marked on your x-axis, and you've got the first x value labeled and the last x value labeled. So it's clear I can tell what your increments are, and I can tell that you've divided this thing into fourths. You don't have to, like I said, give the actual x value at each one of these points. Okay, so the sine graph. I said that it starts and ends at sea level. It hits sea level in the middle. Halfway between the first x value and that midway point, it goes up to this maximum value of 1. So there's this point up here. And then halfway between the midway point and that last x value, it gets down to this minimum value of -1. Okay, so in black there, I've graphed this function. Now we need to deal with the vertical transformations. So now I want to get the actual graph here, the given function, 3 sine of 3x minus pi minus 2. So the vertical transformations are, well here, since it's 3 times the sine function, that's going to change the amplitude. So the amplitude of this graph needs to be 3. You can accomplish that by multiplying, let's see, multiply your y values by 3. Now the other vertical transformation is here. The 2, so the -2, 2 is being subtracted from the value of sine. So that's going to be a vertical shift, in this case down 2. And this brings me to another mistake that I see a lot with the written assignments. So when a value is being multiplied by the function, that's going to be a change in amplitude. If it's a negative value that you're multiplying by the function, then it's also a reflection. When you have a value being added or subtracted from your sine or cosine function, that's going to be a vertical shift in the graph. Okay, so we've got the amplitude of 3 from the 3 being multiplied by the sine function, and then a shift down 2 from that value being subtracted. Now we just need to actually do that to the points on this graph over here. So I'm just going to go 1 point at a time. Multiply the y value by 3. So this first point, and I'm going to need to label a few more values on this y-axis, and see, I never leave enough room because this thing's going to go up to 4. Okay. All right, coming back here. So this y value right here is 0. So when I multiply by 3, it's still 0, and then shift the graph. Whoops, and when I went up to 4, I was thinking of the one that's on your written assignment. This one doesn't go up to 4. It's because we're shifting down. This y value right here is 0. Multiply by 3, it's still 0, and then shift down 2 units. So you get a final y value here. And actually, the new sea level for this graph is shifted down too. So if you like my whole sea level analogy, you can just kind of think of the x-axis being moved down here to this dotted red line. I can kind of prove that to you by if I take this y value right here, it's 0, so times 3, it's still 0, and then shift down 2. If you can read what I'm trying to write there, and I get this point right here. And same for this point where the x value is pi over here. So the y value is 0 times 3 is still 0, and then shift down 2. So I went ahead and moved those 3 points just since they have the same y value, so they all shift to the same y. Now, this point up here, so the y coordinate right here is positive 1. So when we multiply by 3, that stretches the y value up to 3, and then from there we would shift down 2. So just coincidentally here, it lands at that same point where it started. Now another way to come up with this point right here is just to look at, so I talked about sea level down here at -2. We know that the amplitude is 3, so when this sine graph goes up and reaches its maximum value, it's going to go up 3 units from sea level, because that's the amplitude, and then come back down. So the same thing is going to happen down here. This y value, or this point right here between the 2 pi over 3 and the pi. So right here the y value, let me get my pointer, the y value right now is -1. So when you multiply by 3, you get -3. So -3 would be right here. And then from there, shift down 2. Oops. Okay. So let's see. Stretch it down to -3, and then from there, shift down 2. So it lands way down here where y is -5. And I was saying that another way you could come up with that is if you look at sea level and the amplitude is 3, so it's the minimum value would be 3 units down from there. So 3 units down from the -2 would be -5. And then, I mean, at this point you've done it, so if you followed me through all of that, and I'm sorry my explanations get so long, but there in red is the graph of the y equals 3 sine of 3x minus pi minus 2. And if you're still listening, thank you so much for listening to this entire video.